So next we're going to go ahead and create the footprint. So I'm going to toggle over to the footprint view. And just like in the schematic editor, you can use the Q shortcut key to toggle over. So I'll give you a quick walkthrough of this UI. It's the same thing. On the left side, you've got all the tools you need to create a footprint. This is the footprint generator, which is what we're going to use, and this is what you'll be using for most of your footprints. This generates a footprint for you automatically. We have a BGA generator, so this generates BGA footprints. And then after that, we've got all the tools that you need to create a footprint manually. So we have shapes tools, manage your pad stacks, you can add silkscreen text, and then just regular text. You can add holes, and we have a measurement tool, so you can measure distances. So what we're going to do is use the footprint generator to have Upverter create the footprint automatically. So I'm going to go ahead and click the footprint generator. And the way this works is you basically select the type of footprint you want to create from the top. So we know we're creating a QFN. So I'm going to click here and I'm going to scroll down until I find the QFN. It's in the flat no lead category. So that's QFN. And all you have to do is in the bottom here, enter in all of the physical parameters, which we're going to pull directly from the datasheet, and just click generate footprint, and Upverter will generate it for you. So the way I'm going to do this is here it's useful to have the datasheet side by side. So I'm going to go ahead and pull my datasheet tab separately. And then I'm going to scroll down to where in the datasheet they show you the footprint with all the dimensions. So that would be under mechanical specifications. So there we are. I'm going to go ahead and make that a small window. And I'll put that side by side. For the most part, most semiconductor vendors, they label their data sheets using the same abbreviations as A1, A2. Sometimes there are a couple of differences, but you can always figure it out by just comparing the two diagrams together. So let's go ahead and fill this out. So the number of leads on both sides, in this case, is 8. A is the full height. So the full height here is also shown as A. So I'm going to go ahead and type in those numbers. And one thing I should mention is that since the datasheet defines all of the dimensions in millimeters, I've selected millimeters here. If the datasheet was in mils or in inches, you could select that as well. You don't have to do any unit conversion. So let me go ahead and type that in. So the minimum height is 0.8, the nominal height is 0.85, and the maximum height is 0.9. A1 is the package clearance. So here they've also called that A1, so that's 0, 0.2, 0.05. A2 is the package height. This is something that's not really defined in this data sheet, so we're just going to skip that over. We'll leave that one alone. D is the package length. Here they've called it here we call it D in Upverter. In this data sheet, they're calling it E. But you can see that since the package is square, E and D are the same, so it actually doesn't really matter. So we're going to do 4.9, 5.0, 5.1, and again, the lead width is little b, lowercase b, so that is 0.18, 0.25, 0.30. The lead thickness, they've shown here, they've called it A3, we call it C. So A3 is 0.2, which actually Upverter already had in there, which is great. The lead foot length is, you can't see it, I'm going to scroll this guy over a little bit, is L, which we also call L, and here it's 0.35, 0.40, 0.45. The lead pitch, which is the distance from center to center on adjacent pins, also called little e here, and that's 0.5. Do we have a thermal pad? Yes, we do, and you can see that pad is defined in the middle here. what are the dimensions of the thermal pad? So here they're defined as E2 by D2. Again, those are the same values. So 3.5, 3.6, 3.7, 3.5, 3.6, 3.7. The paste coverage, you can leave that at 40%. That's generally fine for most parts. Where is this pad located? What are its X and Y its center offsets? We're going to leave it at 0, 0 because we want the thermal pad to be exactly centered. But if it was off center, you could adjust that stuff here. What is the land shape? So what's the shape of the actual pad and the footprint? We'll stick with a rounded rectangle. We'll give pin number 1 a slightly different shape. We'll make it just a regular rectangle. Packing level, if you're interested in IPC packing levels, which define the density of the design that you're targeting, you can select the packing level here, and Upverter will adjust the footprints accordingly, but we're going to leave it at its defaults. So now you click Generate Footprint, and there it is. I'm going to go ahead and make this full screen again. So as you can see, Upverter has generated the entire footprint, all of the layers. We'll just kind of quickly walk through this. If you open up the Layers tab here, the Layers section, you can see this gives you a list of all of the layers on this footprint. And this is exactly what a PCB layout looks like as well. And you can show and hide any layers from this dialog. So I'm going to go ahead and hide everything and just show the copper. So here are all the pads for this footprint automatically generated. The solder mask, which is shown on top, which exactly matches the copper pads. I'm going to close that. I'm going to show the paste. This is the paste mask, and you can see that the paste mask coverage is only 40% of the total area. You can see that it's smaller there. We have silkscreen. So on the silkscreen, there is a box drawn around the part, and the reference designator will be shown there. And we automatically add a little dot here for pin 1. The holes layer, we have no holes since it's a surface mount part, so there's nothing there shown. We have a courtyard. We support IPC courtyards, so that's defined there. So all the layers you have are defined here. And we also have automatically associated the pins with pads on this component. And you can see that those icons here have been filled in. If you wanted to change the association, so if you had manually created a pad using one of the tools here, you could go ahead and you could change the association of that pad. So what I'm going to do here is I'm going to just show the copper so I can really make it easy to select a particular pad. You can double click a pad. It will open up the pad stack inspector, and from here you can change the pin association, you can change the coordinates of that pad, all the physical parameters, the layer connection parameters for that particular pad. But since we've used the footprint generator, all this stuff is filled in exactly correctly and we don't need to change anything. One last thing I want to show you is the pin arrangement. So you can see here on the datasheet, from the top view of the package, pin number 1 and 2 are supposed to be on the left, and the numbers go around counterclockwise, and you end up with 31 and 32, and that's exactly what we have here. This is a top view we're taking. So as I mouse over, you can see we have pin 1, pin 2, the pin numbers increase counterclockwise, and then we have 31 and 32. So that exactly matches the datasheet there. Okay. All right, so now what I'm going to do is I'm going to go ahead and try to save the design. First, you should enter in a brief sentence about what you've done. This is like a change log for this design. So we created the part from scratch, symbol, and footprint. And I'm going to click save. Oh, but Upverter has given me an error. It has said pin 33 is missing a footprint mapping, which is awesome. What a great thing for Upverter to remind us of, because I totally forgot about that. What that is saying is that remember that extra pin number 33 for the thermal pad that we created? Upverter, the footprint generator doesn't know which pin number to associate that thermal pad with. It actually leaves it up to you so that you can make the right choice. So we have to manually go and associate the thermal pad with pin number 33. And you can see that it's not associated by opening up the pin list, scrolling all the way to the bottom, and you can see the ground pad pin, although it's on the schematic symbol, it's not assigned to the footprint. So I'm going to go ahead and double click the thermal pad, set the pin association to ground pad, and click save. And then we'll try to save our changes again. And there it worked. And remember before I spoke briefly about part pages. You're now taken to the part page for this chip. And this gives you a summary of everything. It shows you a snapshot of the schematic symbol. It shows you a snapshot of the PCB layout. There's a revisions tab, which shows you all the revisions that have been made, all the changes that have been made, just a summary here.